Hi, good afternoon. I'm Joey from Chengdu, China, from Huawei's Enterprise Storage Department, and today I'm going to talk about the Dorado FME 5000, which is actually a middle range storage. I hope to get you through two demos of use cases to show have a direct impression on the performance, reliability, and manageability of our product. So I was planning to, in the first 5 minutes, or maybe even have a quick look at the performance with snapshots on the workload of OTP, and the next maybe 10 minutes, or maybe it's our active feature called Happy Metro. Bear in mind this diagram that I created the other day, and I have built the lab infer in the rack. It's to save this rack to simulate the two separated data center. I get those servers and the storage just totally match this diagram. So I have there is connections between the servers and the storage in both the local side and the remote side, and we also have the arbitration link. So as for the performance, I will go quick at this session. I have logged into host 12 to generate I/O against the volumes on storage 1 to see the automate performance even with the snapshots. So I already logged into this console, and I have already created the volumes previously in order to save time. I get here we get 8 volumes created and present to the host. And right before we run the script, I have the storage written twice in order to get rid of the fresh box thick. Make sure every write is with the P circle. Here we check. We want to go to the host 12 to check the volumes. Using some command that provided by our multiple path, we call the outer path, and I wrapped some script, and it shows us the volume that I created right here, and I'm going to generate the I/O against those volume. And I have created a script right here. I would go using a workload with the 8K averaging size and with 70% of read, totally random I/O against those 8 volume. And I will check how it performed. So for the from the bench side, it will observed about more than 200,000 IOPS with latency with very low latency, about down of 7 milliseconds. Take the switches latency into account. That might be less. We can check also from the monitor software from the array embedded. We have monitor software, or from the unified platform. We got its system report that can it can be charged many Huawei storage. Now we'll see the workload is running in here, and I would run 4 seconds before I take a snapshot, and then present the snapshot to the host to check if it's consistent with the performance. So from the sys reports, we will see it also have about 260,000 IOPS, and latency is quite big. It could be less than 5 milliseconds. As I say, we have some switch latency and some await time at the host side, because it's almost the ultimate of performance of the storage, single storage. All right. So I go to the protection tab to take snapshots. Even I have already taken some place there, so I can still create additional.
Activated snapshot. What does that mean?
So those 8 volumes, I would take it. Is consistency active or not? And we also observe the curve, the performance curve right here. It's quite because it's running on the single storage. So on site 2, there is no IOPS right now. It's almost just a single. So we'll see the IOPS or latency has no impact.
It went down actually.
I would just stop this script and present the snapshot to the host. I will simply add the new snapshot to the log group. I just check the last 8. Add them into the group. And then I do a scan on the, I can do, so I might shut, it's about, I can shut, just stop this and do a scan, and then check the snapshot. Here's the snapshot that I created just now. I would generate a Witbench script very quickly. Towards the this drive letter from SDR to SDY, also with the same workload, and then run the Witbench script. It also can achieve almost the same IOPS and latency. Okay, I will I'll finish it quickly in order to dive into the hypermetro, the active feature. So that is the ultimate performance almost for this mid-range array. So I will use the host 11 and host 21 as for the servers that generate I/O against the hypermetro volume. In fact, I have already created two. I've already created two hypermetro volume in here. I can also launch it from because I can launch it from one server and then I added additional hypermetro volume. And now I'm just trying to, I will check out the, it's the hypermetro value it's already there and it's normal, and we can use VidBench script to.
So the paths are like you can get to all the paths from both sides. So it's 8 paths, right?
Yes. See, we have this command to show directly very impressive impression that we have like 8 logic paths connected to local and also the remote.
Yeah.
So, but we don't have some virtual volume, but just we have every host C2 volume, and they have the same WW number, and yeah. But for the host, it's the same. It's just one. We'll just check. Yeah. I will use 100% of write to show that to better show the hypermetro. I will see we now generate a fixed workload towards this two volume. As by default, I would go directly would go to the storage one, as it can make use of locality, and the data will go across to the storage 2. And we also we can see from the platform, the monitor software, that only side 1 also has some I/O. We also have some IOPS, like 10,000, and for the side 2, there's none. But in order to impress somebody that it's really active, we can change the hypermetro model in real time while the volume in use and have no impact. I can just log into another console and change the command, the model from the host side. So I set the hypermetro model to generate I/O both to storage 1 and storage 2, to let those two storages serve the I/O from host 11. So we can observe from the city report, it will show that the storage side 2 began to accept IOPS. And it's about 5,000. The total is 10,000. 10,000, and each already now received 5,000. Now I'm just, before I do a full injection to show the reliability, I would just create additional new volumes to show how easy it quickly to create this volume. So I create any of the volume on side 1, also on side 2. First step. Yeah. And then step 2, we combine those two volumes into a hypermetric pair from a hypermetric tab. So I just select something by default according to the wizard. So we have create so we have created two new pair and now ready to present to the host, and that's all it. And we have finished the create a hypermetric pair, a hypermetric volume that. And then we present it to the host by adding it to any of the long group that we created previously. So all we have to do is log into the host side and do a rescan, and we'll see what is going. We do scanning on both sides, on the host servers on both sides.
Say hot admin delete.
So so we just generate the script for the new pair from the host 21 and run I/O against those volume. So now both the 11 host 11 will generate I/O both storage 1 and storage 2, and host 21 generate I/O just into the storage 2. So it's quite easy to create the hypermetro, the active service after steps of links. So now I will choose to restart one of the storage to simulate the fault injection. Let me see, maybe I will choose the storage 1 or 2, any of them. So I just log into the GUI and select any of them and do a restart service to after I started storage 1, and the I/O will point into the storage 2, because it will change the I/O path after start the storage 1.
You took down a whole side, right?
Yeah. So from system report, we'll see the side 2, the I/O has just increased dramatically, because the I/O just pouring into the side now. It may take 3 to 5 minutes to have the storage restarted, and then it's wait to be synchronized, because the data is written only to side 2, so it will take time to do a synchronization and then come back to the normal state.